They're kind of the quiet workhorses of our modern world, moving millions of us every single day. We step on, we ride up, we step off, and we almost never give them a second thought. But these complex machines, they have a fascinating and sometimes a pretty terrifying story to tell.
I mean, think about it. We trust them completely, right? We stand there scrolling on our phones, barely paying attention to this huge machine we're on. But what happens when that trust is shattered in the most violent way you can imagine?
So picture this: Rome, October 23rd, 2018. A subway escalator is just packed with cheering football fans. And then, suddenly, it just lets go. That smooth, steady ride turns into a high-speed, out-of-control dive. A total cascade of metal and bodies. It was the kind of event that, frankly, should be impossible. And here's why it should be impossible. These machines are absolute beasts of efficiency. A single typical escalator can carry over 10,000 people an hour. They are engineered to be tough, reliable, and more than anything, safe. So how could one fail so badly? Well, to understand the failure, first, we've got to understand the machine. So let's pull back the curtain and really look at the brilliant engineering that makes these things tick. We're going to start with a solution to one of their biggest early problems, a solution that was just pure mechanical genius. Believe it or not, the very first escalator was actually a theme park ride at Coney Island, way back in 1896. But these early designs, like this one called the revolving stairs, had a huge, dangerous flaw. See, the steps were fixed to a chain. That meant when they got to the top or the bottom, they would tilt forward, which, as you can imagine, was a total nightmare for getting on and off safely. The big problem was how to keep those steps perfectly flat right at the beginning and end of the ride. The solution, which came from an inventor named George Wheeler, is basically the foundation of every single escalator you see today. He realized you don't fix the steps, you let them rotate. And you don't use one track, you use two. Okay, so here's how this brilliant system works. Every single step has two sets of wheels. The main wheels are hooked to the drive chain and they do the pulling, but a second set of wheels runs along a completely separate guide track. By controlling the distance between these two tracks, engineers can control the step's angle perfectly at every single point, making sure it's always completely level when you're on it. And every single one of these steps, it's a little masterpiece of manufacturing. They start out as molten aluminum, get injected into a mold, trimmed by a robot, and then perfectly finished to get that grooved surface we all know. You could put an elephant on a single one of these steps and it wouldn't break. Yeah, you heard me, an elephant. That's how over-engineered they are for safety. All right, so here's a classic escalator mystery for you. You watch the steps slide into the floor at the top or bottom, but what are they actually doing on their tip back underneath? Are they staying level, kind of like cabins on a Ferris wheel, or do they flip completely upside down? They totally flip, and it's all thanks to George Wheeler's two-track system. As the tracks curve around and separate under the floor, the steps just gracefully invert for their return journey. It lets them tuck in really tightly inside the structure before they flip right side up again. It's just a beautiful, simple, and super efficient design. Okay, so beyond those core mechanics, escalators are packed with all these subtle safety features, things you've probably seen a million times but never really noticed. You know the grooves on the steps? They mesh perfectly with that cone plate at the end to kick out anything small that might get stuck. And those little brushes along the sides? They're not for cleaning your shoes. They're there to gently nudge you away from that tiny gap at the edge. The yellow lines? They're just a clear visual cue for the safest place to stand. And here's a really cool one. On a packed escalator going down, the weight of all the people actually starts to drive the motor, turning it into a generator. This not only controls the speed, but it sends electricity back into the building's grid. All right, here's a fantastic little detail. Have you ever been on an escalator and felt like the handrail is moving just a tiny bit faster than the steps? Well, you're not imagining it. On a brand new escalator, it's designed to move about 2% faster. So, why on earth would they do that? Well, the handrail is driven by a friction wheel, and over years of use, that wheel starts to wear down and get a little smaller. If that happened, the handrail would start to lag behind the steps. So by starting it just a tiny bit faster, engineers build in a buffer for all that future wear and tear, making sure it always gives you the stable support you need. Pretty clever, right? So with all this brilliant engineering, all these backup plans and safety systems, we have to come back to Rome. What on earth happened? How did a machine that's so fundamentally designed for safety become an instrument of absolute chaos? The investigation uncovered this horrifying cascade of failures. First, the motor just got overwhelmed by the sheer weight of the crowd and it started to slip. That triggered the primary safety brake, but it was incredibly weak. It was only gripping with about 37% of the force it was supposed to have. Then, the final line of defense, a purely mechanical backup brake, was supposed to kick in. But investigators were horrified to find it had been deliberately tied open with plastic zip ties. It was completely useless.
And the story got even darker. The investigation found that the onboard computer system that logs safety errors, it had been intentionally disabled, so critical problems were leaving no record. The maintenance logs were either missing or had been faked. The escalator hadn't just failed, it had been systematically and dangerously neglected. And this chilling quote from a wiretapped conversation with a transit manager really says it all. The disaster in Rome wasn't a failure of engineering, it was a profound failure of people. A story of neglect, of falsified records, and a truly shocking disregard for public safety.
Now, while that disaster in Rome was an extreme, horrifying case of negligence, it's a good reminder that for the billions of safe trips we all take every year, our own behavior is still a key part of the safety equation. So let's just go over a few simple rules to keep in mind. Okay, the big one is this. Always hold the handrail. It's there for a reason. Always face forward and pay attention, especially when you're getting on and off. Of course, keep a close eye on any children with you, and please never sit on the steps and try to avoid running or walking. Also, just be mindful of anything loose, untied shoelaces, long scarves that could get caught. Simple habits like these really do make a world of difference. Ultimately, an escalator is an incredibly safe and robust piece of engineering. The systems are designed with these huge safety margins, but the story of Rome is a powerful reminder that the strongest chain of safety features is only as strong as the human link that's responsible for maintaining it. And that leaves us with a really critical question. When we step onto any complex system, who are we really placing our trust in? The machine or the people who are supposed to be taking care of it?